Okay guys, today's video I'm going to give a complete demonstration and setup of the GPS radio link devices. And I have right here hooked up, I have the mobile side. This is what's going on. There's a GPS unit there, and this is what's going onto the radio. This green wire here represents the radio path, where you'll have two radios in between there passing the audio, and this is the receive module here that decodes it and turns it back into RS-232 for the distant NPC. I got the oscilloscope hooked up so you can see the FSK audio as it comes out of the mobile and into the receive here. And yeah, I'm going to go through the complete schematics of both modules of the transmit and receive, and show you how that all goes together. I was waiting for the chips to get in, the MX614 chips. I got both the dip style, which they don't make anymore, but I found a few left out there for sale, and they also have the modern SOIC version, which after coming and getting a little bored and soldering it up, I had a lot of fears about doing that, but it turns out it's actually really easy to do. So that was not a problem. And so the only thing I really have left to do majorly is to get on the KiCAD program and whatever, and come up with a printed circuit board for each one. So I don't have to manually put it together. I couldn't do that in quantity. But the circuits are good, the concepts are good. They were actually using these old MX614 chips long ago with some initial ham radio stuff, so the circuits and everything has been tested and true for a long time. Now it's just a matter of putting them into a little box on this side attached to the radio, and this side I got the USB and the COM port coming out to go with the PC. So I'll give you a close-up look at each one here. So let's see what's going on. And that's my miniaturized Arduino Mini Pro, or Pro Mini I should say. And yeah, for 15 bucks it's incredible. And here's my receive side over here, where I got the FSK tones being turned back into the RS-232 with this system and inverter chip. But and then over here you can see my GPRMC sentence streaming out of my receive module. And then I have the oscilloscope showing the FSK tones as they come out. So, but yeah. Anyway, that's the demo portion of the video. Now I'm going to switch and go over both schematics for both modules and go from there. So stand by. Okay. Here we are at the schematic of the circuit, and I'm going to start off over here on the left at the Garmin 18X. The Garmin 18X LVC, its max baud rate is 19.2, so it's you can't do the same as the 38.4 as the 16X, but it's still way fast enough to get its chirp in and plenty enough time for the 1200 baud to finish it off before the 1 second is done. So, but we have it programmed up for the one sentence of GPRMC, and it's sent out once a second. And that RS-232 signal comes out of the white wire here, and we have it going through a CD4049 hex inverter chip. And this is to change it from the pseudo RS-232 0 to 5 volts to the TTL 5 to 0 volts, the inverted version of it, which the Arduino Mega down here speaks. So we come out of here at TTL and we go into the Pro Mini. We do the baud rate conversion using the sketch program over here, and output the sentences at 1200 baud coming out of the serial to where they're fed into the MX614 chip on pin 11 here. Now the MX614 transforms the zeros and ones of the data coming in into 1200 hertz or 2400 hertz tone symbols coming out. So these come out here. This would be your deviation pot for your transmitter, and output the FSK tones into your microphone input of the radio. Now your push-to-talk control on your radio is going to be a separate cable that comes off of your radio, and it's up to you how you want to run that. And also it's a possibility, because I think on mine, even though they are electrically isolated in a lot of ways, I can still barely hear the FSK in the background when I'm bringing it into the auxiliary mic port. So I'm going to run a double pole single throw switch, so that there's no audio on the back of the radio or push to talk until the switch is depressed. So, but anyway, this is the output to the radio, and of course it just transmitted over the air to the other side. Here on this circuit, we have the 78L05 5-volt regulator, and that's because I'm running the board off of 12 volts from the radio. The 12 volts coming from the radio is a fused, already conditioned wire that comes out the back of the accessory port on the BK radio. So it's already good to go. I don't have to worry about doing anything else to it. The other thing too is the 1 pulse per second LED. This would be optional. You don't have to have it, but it just gives a sign of life for the board that comes in handy, and also to let you know your GPS is alive and well. So anyway, that's that for that. Let me go ahead and switch over to the base drawing. Now this would be coming from the other side. This would be at essentially the dispatch side of the world, where your base radio will have with I call it low-level audio output, kind of like directly out of the discriminator there. But whatever audio source that you have coming from the radio for those tones, you need to make sure that these two resistors right here, when they added together, match the output impedance of whatever source that you have, so you get your maximum power transfer over here. These back-to-back diodes here, these are for level clipping. So in case you try and exceed 0.7 volts on either side, it'll just flatten off the tops of them, because this is a op amp fed high impedance input, and it doesn't really need much audio at all to do its little decoding. So once the tones come into the MX614 chip here, like I said, the 2400 and 1200 hertz tones are converted back to zeros and ones and fed out on pin 13 here at a TTL level. Once again, I'm using the 4049 chip to do the inversion and turn it back into RS-232 for the output going into the your PC or laptop or whatever computer device you have out here. I also have just taking an old junk USB cable and robbing the ground and plus 5 volts here to let the PC run, give it power. No reason to do anything else. The 5 volts from the PC is great. And once again, I have an optional power indicate LED up here. It's not necessary, but it just gives a kind of warm fuzzy. And yeah, this chip here, like I said, it was the that little SOIC pack, and they soldered up really nice. I went ahead and tinned the little adapter board first, and I watched the video, and it looked too easy on the video. So, but it was really quite that easy. If you just put a little dab of solder and just draw the tip back, and it just seems to want to go on there perfect. So, very happy with that. But there you go. Okay, that's the decoder for the base side, and once again, this is the encoder for the radio side. So, and I made previous videos about how to program the Pro Mini and how to put in the Arduino sketch. I also made another video about how to set up the Garmin GPS. So I'll give a further update in the future when I get the Gerber files made and actually get a printed circuit board and show you what that looks like when that eventually shows up. So otherwise, we'll talk to you soon.